Today we are talking about 9.5, more equations. And just like before, we're going to focus on labeling the equations before we start. Again, when we add more equation types in there, it makes it more complicated to tell them apart when they're all mixed together. Number 1, log base 2 of 4x plus log base 2 of 5 equals log base 2 of 20. Initially, this looks like log equals log, and like you would just drop all the logs and solve, but that would be a huge mistake if that's how you chose to handle this problem. Notice we have 2 logs on the left and 1 on the right. That is unbalanced. You can only have 1 log on each side. So our current situation is 2 logs equals 1 log. And we can't work with that. Again, what we work with is log equals log, 1 on each side. So we need to get 2 logs down to a single log. We're going to condense. So that is the very first step, condense. On the left side, there are no exponents, so we just have to use the symbol in the middle. This plus tells me I'm actually just going to multiply the 2 terms together. We end up with log base 2. And then 4x times 5, that's just 20x, is equal to log base 2 of 20. Now we have the log equals log problem. And we can solve it how we normally solve a log equals log. 3 steps. Drop, solve, check. So I'm going to drop the logs. And we have 20x is equal to 20. And then we just need to get rid of the 20 on the x. So divide both sides by 20. X is equal to 1. 20 over 20 is 1, not 0. And since we have a log equals log, we must check. Now here's the thing. You can check with the original equation, of course, but technically the issue came in when we dropped the logs. So that was after we got log equals log. So it's going to be most beneficial to you if you plug it into the equation where it was at log equals log before we dropped. This is the most condensed version, and you'll be able to tell that your answer is also correct, not just that your answer is no solution. So I'm going to go from this part of the equation before I drop the logs. That's where I'm going to plug it into. And we're checking that x is 1. So we have log base 2 of 20 times x, which is 1, equals log base 2 of 20. And then 20 times 1 is obviously 20. So log base 2 of 20 equals log base 2 of 20. So a couple things. These are both positive, which means it passes the check, and we got the same number. So we know for a fact that our answer is correct. X is indeed 1. Any questions on number 1? Okay, moving right on to number 2. Log base 3 of 56 minus log base 3 of x equals log base 3 of negative 7. Again, let's label, identify what type of problem this is. We have 2 logs on the left and 1 log on the right, so we have the same setup here. 2 logs equals 1 log. So again, the same protocol. We have to condense first. And again, condensing is not optional. If you don't do it, you will get the wrong answer. So let's condense. No exponents to deal with. We just have this minus in the middle, which tells us to divide. So we have log base 3. And then when we divide, we have to go in order. 56 divided by x, 56 over x, equals log base 3 of negative 7. Now we currently have log equals log. And then log equals log. The method, the way, is drop, solve, check. So now we can drop the logs and just bring down what we have. 56 over x is equal to negative 7. First off, a lot of students get stumped when they get to a setup like this. We don't see this very often, even in Algebra 1 or Algebra 2. So here's the way to go about it. X being on the bottom of the fraction is not helpful. It can't be solved when it's stuck down there. So our first thing we need to do is move the x. So this is currently being divided by x. The opposite of that would be multiplying by x. So times x on both sides. And that's just going to cancel over here and give us 56 equals negative 7x. And then we'll just divide off the negative 7 on both sides. X equals negative 8. And then we check. We are checking that x equals negative 8. And as I mentioned before, we can do it from the very beginning, but a shortcut is do it from the log equals log setup. That's going to save you time, and you'll know for sure that your answer is correct. So I'm going to go from this equation. We have log base 3 of 56 over negative 8. And I'll put that in parentheses. It just looks a tad nicer. Equals log base 3 of negative 7. Log base 3. And then 56 over negative 8 is indeed negative 7. That is true. But you can't plug a negative into a log. So since these are both negative, this does not pass. Our answer is no solution. Now, who noticed that our answer was no solution from the start? Did anybody? Few of you? Good. This was set up from the get-go to be no solution. If you paid attention, you would have seen one of the logs already had a negative in it. So this was bound to fail from the start. So keep an eye out for that. We don't do that very often, but that was the only way I could make an equation that failed. So that's how I made that one. Yes.
So then would you still have to solve it?
If you could give me an explanation explaining why it's no solution, I'd accept that. Yeah. Okay, so because of this outcome, we have no solution. Questions on number 2 before we move on to number 3? Number 3, this will be our last log equals log problem, and then we'll move on to a different type. Log base 4 of x equals 1/4 log base 4 of 81 plus 1/2 log base 4, 25. This is going to have a little bit of work on the front end, but the equation is going to be very straightforward. So this time we have 1 log on the left, but 2 on the right. So we have the same thing, it's just flipped. 1 log equals 2 logs. And again, if you have 2 or more logs, you must condense. And this is going to take a few steps. First off, we look for exponents, and we do have exponents this time. We've got 2 of them. The 1/4 and the 1/2 are both exponents. Move them to the end of their own logs. And I'll rewrite. We have log base 4 of 81 to the 1/4 plus log base 4 of 25 to the 1/2 Now, if you don't do it at this point, you're going to have to do it later, so you might as well. Yes, we're going to get the value of these numbers, and they are nice whole numbers, not decimals. So that's what we'll use our calculator for. 81 caret, and then we'll have 1 ABC4 for our fraction. This becomes log base 4 of 3 plus log base 4 of, we'll do 25 to the 1/2. That is 5. And then bring down the left side. One more step and then we're fully condensed. Now that we've taken care of the exponents, we can take care of the plus in the middle, which tells me to multiply the 3 and the 5. So we get log base 4 of 15 on the right, and the left just keeps coming down. Log base 4 of x. Finally, we are at log equals log. Meaning we follow the steps. Drop, solve, check. And when we drop, the logs disappear and we just have x equals 15. Meaning we don't actually have to solve anything. So then we do our check. We're checking that x is indeed 15. And again, we're checking from where we got to log equals log before we dropped. So right here. We have log base 4 of x is 15. Equals log base 4 of 15, which I wasn't really needing to do anything. We just plugged it in and yeah, it matches and it's positive, so we're good. That would be a check that you could definitely just do by looking at it. X is 15. Now the one downside is this relies heavily on how well you did the first half of the problem. If there's a mistake here, it wouldn't be caught in the check. So, something to think about. Questions on number 3 before we move on to number 4. Okay, number 4. Log base 2 of 2x plus 6 minus log base 2 of 3, or log base 2 of x equals 3. We have a different problem type here. Right now we have 2 logs on the left and a number on the right. So this is 2 logs equals number. Still not acceptable to have 2 logs on one side of an equation, so you must condense. So we condense. No exponents this time, we just have to condense these down to a single log. This minus here tells me I'm actually just going to be dividing the 2 terms here. We have log base 2, 2x plus 3 goes on top, 2x plus 6 goes on top, over x goes on bottom, equals 3. Now we have 1 log on the left and then just a number on the right. So we are at log equals number, which we know how to solve. Log equals number means we switch the form and solve. No check is required. Okay, so I'm going to switch the form. We are currently in log form, and I want to change it to exponential form when I drop it down. Base stays base. My base here is 2, and it's a big 2 this time. The other 2 switch over. This is 2 cubed on the left, and 2x plus 6 over x on the right. This looks complicated, I assure you it's not. Just go a step at a time. Now we have exponential on the left, but we don't have exponential on the right. So we just figure out what 2 cubed is, which is 8. So I'll replace 2 cubed with 8 equals 2x plus 6 over x. And then we just had this same scenario on the front side, where we had an x in the denominator. Again, that is not helpful to anyone, so let's move it. If it's being divided, we multiply both sides by that x to get rid of it. So this x is gone on the right. We have 8x equals 2x plus 6. Two steps to solve. Again, reminder, when you have 2 x's on opposite sides and you have to move one of them, if one of the x's is by itself, do not move it. Keep it over there. So I'm going to move the 2x. Minus 2x on both sides. We have 6x is equal to 6. And then we divide off the 6 on both sides to solve for x, leaving me with the answer x equals 1. That problem took a while, but I didn't think it was too bad. Questions on number 4. Okay, we got 2 more. These next 2 are going to be a bit interesting. Number 5, 3 log base 2 of x is equal to 6. So this one looks a little different. We have a single log on the left side, yes, but that 3 being in front of the log is still an issue. There are 2 ways to go about solving this problem, and I'm going to show you both. I will show you the easier and, in my opinion, better way the second time. But I do have to show you the, quote, proper way to solve it based on what we're teaching you in this unit. So forgive me on that front. So our current situation is we have 3, this is 3 times log, equals a number. That 3 cannot be there if we're going to solve it by switching the form. So that 3 being there is an issue. We need to get rid of it. Again, we can do that by condensing. When there's a number in front of the log, we are aware that it just moves to the end of the log and becomes an exponent. So we have log base 2 of x cubed equals 6. And now I have the situation log equals number. And when you have log equals number, you switch form and solve. We are currently in log form. And I need to switch it to exponential form. Base stays base. My base here is 2. The other 2 switcheroo. 2 to the 6th, and then x cubed goes on the right. We're going to pull out a couple old algebra tricks in a sec. 2 to the 6th, we can just use our calculator for that one. 64 equals x cubed. How do I get rid of a cube? Yeah? Exactly. It's like a square root, but we use a 3, so we use a cube root. Cube root both sides. So on the right side, that's going to cancel out the 3's and just give me x. Follow-up question. Who remembers how to enter a cube root into the calculator? Harneet? One more time? Yes. So let me explain what she's telling me. She's 100% correct. So on the calculator, we have the x squared, and above that you have the regular square root. And then you have the caret, and above that, it's kind of hard to see, but that's an x. That x can be any number. That's the root I have to use. But first I need to tell the calculator which number I want it to be. So you hit the 3 first, and then it's second caret, and the calculator reads this as a cube root, and then the number underneath, so 64, goes next. Cube root of 64 is 4. And that is our answer. Now let me show you the easier way. If you don't focus on using log properties, you could take a far more just algebra approach to this. The other way, we have 3 log base 2 of x is equal to 6. Just think with your algebra brain. That 3 is a problem. It's in the way. I want to get rid of it. How could I get rid of the 3? Not subtract. Divide. There we go. Because remember, this is multiplication here. So division, we'll get rid of it. Divide by 3 on both sides. Now we have log base 2 of x is equal to 2. And now we are at log equals number, so we switch form and solve. So we're going from log to exponential form. Base stays base. My base is 2. The other 2 switcheroo. 2 squared on the left and just x on the right. 2 squared is 4. 4 equals x. There you have it. So you are more than welcome to solve that way if you prefer. Questions on number 5 before we get to our final problem. Okay. This one's different from the other problems that we've done so far. It'll throw you for a loop. Definitely going to make sure you get some practice with these. 6 to the x minus 2 equals 50. Currently, we have an exponential on the left and then a number on the right. Now, I could have labeled it previously. I just didn't think about it when I did those notes. But this would be exponential equals number. That's what we're working with right now. When you have exponential equals number, there are two ways to solve. And by the way, we've already done problems like that. That should look semi-familiar, but the approach is going to have to be different. So when we taught this before, when we worked on this before, the method, the approach was to get the same base. That's what you were taught to do. That's what you're conditioned to do, so let's do that. You can't break the 6 down. 6 breaks down into 3 and 2. 50. 2 and 25. And then the 25 breaks down into 5s. What is the issue? There's a few of them.
They're not the same.
What's not the same?
The numbers. You break them down.
Which numbers?
6
Exactly.
5.
So I can't get base 6. That's not going to happen. And as I already mentioned, I can't break 6 down even further. Not only the fact that I can't get base 6, you can't turn 50 into a base at all. On the previous quiz, I had several students who tried that on a certain problem where it broke down into different numbers, and so they did one of two things. They either just ignored the extra number and pretended it wasn't there. Obviously, that was wrong. Or they put both numbers together in the base and tried to make a different base out of it. That also does not work. So, if you end up with something like this, you have two options. You either try to break it down a different way, which I can't do. I have broken down 50 the only way it can be broken down. Or you do method number 2, as I'm about to show you in a moment. So here is our current issue. Can't get the same base. With 6 and 50. And before today, any problem I gave you, you could do it. You could break it down. But going forward, that's not always going to be the case. So you'll have to default to method number 2. Just like log equals number, you switch form and solve. Here's the benefit to this method. It always works. If you have an exponential on one side and a plain number on the other, this method is always an option. Will always get you to the right number. So if you don't want to mess with breaking down the bases and just default to this method instead, it's reliable. So I'm going to rewrite the problem and I'm going to solve. We have 6 to the x minus 2 is equal to 50. We are currently in exponential form. So for once, we are switching it into log form. It's log form, so you start with log, L-O-G. Base stays base. My base this time is 6. Step down when you write it. It's a small 6. The other two switcheroo. So the 50 goes in here. And then the x minus 2 goes over here. This is our equation. Log base 6 of 50, we just learned how to do this the other day. We know how to turn that into a number that we can work with. And I'll write the work for it over here for anyone who needs to see that. So we have log base 6 of 50. Remember, we can draw the line to see how the numbers should shake out. So that means we have log of 50 divided by log of 6. Don't forget that you put a log on bottom as well. And then we use our calculator to get that answer. Make sure you type log both times. Log of 50 in parentheses divided by log of 6. And just like before, we'll just round to 2 places. 2.18, the next number is a 3, so we will not round up. So in the equation, I'm going to replace the left side with 2.18. Bless you.
Oh, right.
Equals x minus 2. Lastly, we need to finish solving for x. We just need to move the negative 2. So I will add 2 to both sides. And we're just adding the whole numbers here. So this will become 4.18 equals x, and we're done.